So we've talked about entities, relationships, and now let us talk about the third component, which is keys. This would complete all the components that we need to create our data model. Now every entity will have data related to that entity, and there will always be a need to find a specific instance or a specific data. So those data elements that allow us to find that specific entity instance are called keys. The first one to know about are the candidate key and primary key. A candidate key is a data element or a combination of data elements that uniquely identifies an entity instance. Elements can be considered to be a candidate key if they have no null values, they don't have duplicate values, and their values never change. So again, a candidate key is a column or a combination of one or more columns that can uniquely identify a data row. So like I said, there can be one or more than one elements that might identify a unique row, but ultimately we have to choose only one, and that is called the primary key. Let us take a look at an example. In this diagram, we have data for student entity. So now, let us take a look at which elements of the student entity can be a candidate key and which can be the primary key. The first element is student number or student ID. And if you remember the conditions for an element to be a candidate key, it should not have nulls, it should not have duplicates, and its values cannot change. So considering that, we can say the student ID can be a candidate key because the student ID will always be unique, cannot be null, and will never change. The next element is first name, and we can see that the first name is repeating. Joe is appearing twice. So it fails the criteria of being unique, and that is why it cannot be a candidate key. Same goes for the last name. It also has duplicates. So the last name also cannot be a candidate key. But if we combine the two elements, first name and last name, together they pass all the criteria of being a candidate key, because then the first name and last name become unique. They're not having any null values and they cannot change. So the combination of the two elements can be a candidate key. Okay, now we have two candidate keys. To choose a primary key, we will need to choose one of the candidate keys, and typically we choose the one which is shorter and more secure. This is because shorter key helps in performance when querying the data, and the primary key will be used in a lot of queries, so we should always avoid the elements that can have sensitive information. In our case here, out of the two, student number is shorter because it is just a number, and there are no names involved, so it can be more secure. So student number becomes the primary key. Next, we will talk about foreign key. In one of the previous slides, we talked about referential integrity, and we had said the referential integrity helps in making sure that there are valid values when a relationship is defined. A foreign key concept helps in implementing that rule in the database management system. A foreign key is a data element that provides link to another entity and allows the database management system to navigate from one entity to another. Now, when a relationship is created between the entities, then the entity on the many side or the crow's feet side inherits the primary key of the entity on the one side, or the one which has two parallel lines. For example, let us consider two entities, student and course. The primary key of student entity is student ID, and using the same criteria, we can say that the course ID is the primary key of the course entity. Now we know that a student can have many courses, so student is on the many side of the relationship and will inherit the primary key of the course entity. So as shown in this example, course ID is added as another element to the student entity and is considered as a foreign key. So we've talked about what primary keys are. We used example of student entity and also course entity and defined the primary key based on the elements of instances or values of the column. There is another way of defining the primary key for an entity, and that is by generating a number in your own system. So rather than using the elements that are used by the application, we create our own primary key using a generated number. This generated number is called a surrogate key. A surrogate key has the following characteristics. It is typically an integer. It has no meaning. You will not be able to know the meaning of that row of data based on the surrogate key value. It is not visible to end users. End users should not see the surrogate key in a report. And it can help in reducing the impact of business requirement change. Now, this is the most important reason of having a surrogate key. Let us use an example to see how it can help us in reducing the impact of a business requirement change. We again see two entities, student entity and the course entity. We know student and course entities are related to each other, and student entity has the course ID as a foreign key. Now, let us say that the requirements change and the business wants to store course ID as numbers rather than alphanumeric. They want to change the data type of course ID column. Now, because of this requirement change, we will have to make the structural changes to both the entities. We'll have to make the change to course ID in course entity and also in the student entity. But if we have the course entity defined in such a way that there is a generated number or surrogate key as a primary key instead of course ID, that surrogate key is used as a foreign key in the student table, then we can avoid any changes to student entity when we make a change to the course entity. When we change the data type of course ID in course table, we don't have to change anything in the student table because student table is now referring to the surrogate key. Please note that I have surrogate key labeled as course SK, where SK stands for surrogate key. The other advantages of surrogate key are surrogate keys tend to be compact data type, such as just a 4-byte integer. Now, this allows the database to query the single key column faster than it could do the query with multiple columns. Furthermore, a non-redundant distribution of keys causes the resulting B-tree index to be completely balanced. Surrogate keys are also less expensive to join than the compound keys or the natural keys. Now, there are some disadvantages too, because we might have to create an additional index on the application columns that was supposed to be the primary key or the natural key. These additional indexes, however, will take up disk space and slow down inserts and deletes. The second disadvantage that I can think of is that the surrogate key can result in duplicate values if the natural keys are inserted one more time. However, I think that having surrogate keys is always important, and we can overcome the disadvantages by implementing some workarounds.